the function is equals to y equals to x sine 1 by x. Now we are going to figure out how does this function actually works. So first thing first, we are going to learn how does the function actually look like in a graph. So it's a little bit different than usual. So we can kind of see if we use some programs like Desmos and all that, we can see that it kind of keeps oscillating. Yeah, it kind of keeps oscillating around -1 to 1. Means from -1 to 1, it oscillates. It doesn't stay fixed at one certain point. And then suddenly, given like this. Like in this region, you can see that it shows some oscillating phenomena. And then now we're going to learn if its y is continuous or differentiable at x equals to 0 or not. So for continuity, we have as we know, if we want to declare a function continuous, we need to have left hand limit equals to right hand limit equals to f of 0. So here we have f of 0, basically 0 sine 1 by 0. As you can see, we can see that this is basically, this is supposed to be undefined because sine 1 by 0, sine infinity doesn't exist. But since we did multiply here, we can just call it 0. Makes sense. Then, when I do the left hand limit, we have limit is equal to 0 minus x sine 1 by x. So what we have here? So first of all, we're going to see that this is 0, and since this is basically less than 0 but is extremely close to 0, let's consider this h, so we can consider it 0 minus h. So then we have limit, we'll just get h tends to 0. And instead of x, we're just going to substitute it with y2 0 minus h, and we have 0 minus h sine 1 by 0 minus h. Okay, so we have now h tends to 0, 0 minus h sine 1 by h, which is to be equal to minus 1 minus of course. We can just write it 0. Okay, because it's minus 0. Now, if we're going to right order, we have h tends to 0 plus, we have x sine 1 by s. So it's basically like it goes from 0, but it's greater than 0, but it's extremely closer to 0. So this is considered as h, 0 plus h, so we can just write that limit h tends to 0, and 0 plus h sine 1 by 0 plus. As you can see, it also ends up like h is basically 0, so it also becomes 0. What does that mean? You can see that this one is 0, and this one is 0, and this one is 0. So it's continuous, right? Now, let's just check it if it's actually differentiable or not. Like for differentiability, we have to figure out left hand derivative equals to right hand derivative, whether it's true or not. So let's go back to left hand derivative. Is equal to 1. H tends to 0. H is extremely small number, and we have f of, since we're figuring out for x equals to 0, let's just write it as 0. Left hand derivative 0 minus h minus f of 0 divided by minus h. Why minus h? Because you can see that f of 0 is supposed to be greater than f of 0 minus h. It's the condition for the limit. So then we square it h tends to 0, and we have 0 minus h. Means it's basically um, less than 0. Okay, so we have 0 minus h sine 1 by 0 minus h. Minus we see that it is 0 basically 0 minus h, and then we have 0 h tends to 0, which is basically like this. because we just took this minus figure as one to plus and we get something like this. Now we can just put it here and we get is material minus 7 minus. That's the catch. We don't know anything about this one. Like we were just applying a police minor, then what do you have? You can try that out. Like it's just applying a police minor, which is basically we have explained as 60 by 2 factorial. This is 3.5 by 5 factorial, I just I don't know. Yeah, so here instead of x, we're just gonna multiply because instead of this, we're just gonna write 1 by x. Since there is a minus, we just multiply by 1. So it's basically simple. Okay. If you like it like that, then we're just gonna write it. It's interesting. We have 1 by it, which we're just like common, taking the minus common, then 1 minus 1 by it, 1 by minus, and 1 by it is 32, and 2 factorial plus is negative 5 by 5 factorial by negative. And don't forget there is actually one case here. Which one is that? No, there is actually no answer. So we can try it. So if we just multiply, we're just going to write it as 1 by 0 minus we just going to 1 by 0 minus 9. We're going to like not infinity, right? So since everything is minus plus, so we get plus minus infinity. It's not the infinite value, is it? It's not. So just figure it out for right and derivative. The right hand derivative is like x plus 0. We have 4 0 plus h minus equals 0. We have 4 plus h extra and h plus 0. Okay, so we have 0 plus h from and then we have 0 plus h minus which is 0. And what we have h sine 1 by h equals 4. So we pretty much get the same exact thing as before. There is no need to just figure it out with my previous series. We don't need to use that. Instead, we could just write it as basically a plus minus symbol. And then, that's not it. So, since given here, our left side equals to right hand, left hand derivative equals to right hand derivative equals to plus minus symbol. Great. So, does it mean that y is actually differentiable? Y is differentiable like x equals to 0? No, it doesn't. Why? Because you have to remember that in order to get a differentiable answer, we need to have a finite value, and plus minus infinity is not one of the finite values. It's infinite. So there is not a certain value that satisfies both the left hand derivative and right hand derivative. So it doesn't satisfy this equation. So how do we actually make it look like? So it looks like that it actually does not. It's not differentiable. It's not differentiable at all. So just a basic conclusion we came, right?